All right. So first off, I'd just like to thank everyone for having me. This is an awesome community to be involved with. So I feel very lucky to be able to share with people. So if you guys have feedback at the end, I'd love to hear because I'm trying to learn more myself about this stuff. Today, though, I'm going to be talking about SQL Server and hacking it on scale with PowerShell. The focus of the talk really revolves around weak and default configurations in SQL Server and how they can be leveraged during red team and network penetration testing events. But it's also valuable to DevOps and sysadmins trying to kind of gain a better understanding of what the attack surface of their SQL databases are, especially in an Active Directory environment. As I mentioned, my name's Scott. I'm a network and application penetration tester by trade. I'm not a DBA and I'm not a programmer, so like I said, I'll take all the feedback you have to offer at the end of this. I have, however, shared some of my pen test experiences, tools, techniques, tips, etc. Through blogs at NetSpy and some slide snippets and codes for those who are interested offline. But today, this is the overview we'll be covering. I'll talk briefly about why I chose to target SQL Server as a medium over others, and why I chose to use PowerShell as a language of choice. I'll also introduce a toolkit I wrote in PowerShell to attack SQL Server, and then we'll get into some techniques and how those techniques can be leveraged with PowerShell within PowerUp SQL for finding SQL servers, escalating privileges within SQL Server from different attack perspectives, and then we'll kind of wind down by talking about what do attackers typically do after they've taken over the environment and the databases, and some general recommendations that you guys can take offline to help kind of prevent some of these things. So I love SQL Server because it's just this incredible, robust database platform, and it has like almost as much functionality as an operating system does, which is awesome. And unlike some of its competitors like Oracle, MySQL, etc., it integrates very, very tightly out of the box with Windows and Active Directory domains. And so as a result, it has trust relationships that those others don't that we can leverage from an attacker perspective. So it's not just good to target for data stores, also it can be then used to actually escalate privileges on the domain. I have programmed in some other languages before, but the reason I chose PowerShell was largely because it's native to Windows, and as an attacker, when I get on a system, I don't want to have to pull down a lot of toolkits that might get flagged by antivirus or something else. So it's nice to have basically everything I need just waiting for me there on Windows. Other really huge advantages to PowerShell, which a lot of you guys probably already know, we can run all our commands and memories without putting files to disk, and anything we can dream we can pretty much do because we can wrap .NET code, and we can actually use .NET to wrap unmanaged code, which makes it incredibly powerful kind of as a programming medium. So PowerUp SQL, like I said, is a PowerShell toolkit for attacking SQL Server, and the reason I originally decided to start this project was because I had a lot of onesie-twosie attack scripts I had created, and it just took a long time to run them on scale against even a single server, much less a large environment. So that was kind of my first motivation, and then there's kind of more of an altruistic motivation, which was to kind of help people out a little bit. There's this guy called Will Schroeder in the PowerShell community who specializes a lot in Windows escalation, so taking a normal Windows user and getting them administrative rights over their system. So he actually wrapped a lot of different techniques with PowerShell so that you could more or less press a button and go from user to admin very quickly. And this was great for penetration testers because they can illustrate the risk of some common misconfigurations to their clients, but it's also great for sysadmins because when they're building their gold images to deploy to their entire environment, now they can test them for all these common escalation issues that they may not understand in detail, but now have enough information on to actually create a kind of corrective change. So I wanted to do that same thing for SQL Server in particular, or at least start to do that. So once I decided I was going to do the project, I realized there were a few problems I had to solve first. The first was scalability. I really wanted to be able to run these on scale, and I started off playing with PowerShell jobs, and every time you run a new job, it spins off a whole other process, and I had about a 50% crash rate on those processes when I was playing with it initially. So I kind of scrapped that and went looking for other options, and I came across a really awesome blog series by this guy named Bo Prox. I hope I'm saying his name right. It's a 3-part series on run spaces, and it just opened my eyes to kind of this pseudo multi-threading through PowerShell using some .NET stuff. So I started playing with that and building my own functions just to kind of understand how it worked and how I could potentially use it in the toolkit. And during that exercise, I actually came across someone who had already written this very robust parallelization function called invoke parallel. And I think his handle is PS Cookie Monster. I actually don't know his real name. It's Warren F. everywhere I see, so I don't know his last name. If you know him, thank him for me. But it's because of those guys' work, community work, that I was able to understand and actually execute on these run spaces, and that's really what makes PowerUp SQL so scalable. The next thing was flexibility. I wanted all my functions to work together seamlessly, and so the kind of claim to fame for PowerShell is obviously the pipeline and taking very complex code and reducing it to basically 2 commands separated by a pipe, right? So I'll show examples of how that worked. That was largely driven by the use of PS objects and data tables, and actually a lot of my data table knowledge came from Chrissy's blog series, so go check that out as well if those are something you're interested in. I'm now officially addicted to data tables. Lastly, I'm a pen tester, so portability is really important to me. I need the ability to carry these scripts from system to system, and I need them to work every time. Excuse me. So I started reading books on how do I use PowerShell with SQL Server, and most of the books said use these SMO libraries. So when you install SQL Server, you get a series of or set of DLLs, and they're really great. They're incredibly powerful, but as an attacker, I'm not always on a database. Sometimes I'm attacking from a user workstation or another server that doesn't have SQL Server installed. So I didn't want to have to lug those libraries along with me. And so I decided to lean on the .NET framework and the SQL client library within. And so that gives me a lot of portability. And as I started building it, a lot of people in the community pushed me to try to build it for PowerShell version 2 so that it can be compliant on Windows 7. Which is still out there in a lot of environments. So in theory, it is working right now thanks to the help of a lot of people out there who would give me good advice and a few pull requests on GitHub. The last thing I did was put everything in a single file, and real programmers hate me for this, which is probably justified. But the reason I do it is because I want to have a single file that I can use during SQL injections, or if I need to pull it down during a red team engagement, I only want to do one request out to the internet or to another system. So it really allows me to minimize kind of my network traffic and behavioral footprint when doing that. To kind of manage all of those functions that I have, I've been using ISE a lot. Historically, I've used the Function Explorer add-on, which was awesome, but is now deprecated. And so now I really lean on ISE steroids to kind of manage the code base effectively. Once I troubleshooted all those things, I had to move on to functional goals. These are the core ideas behind PowerUp SQL. I want to be able to discover SQL servers very quickly from different attacker perspectives, inventory things like configurations, database tables, etc., and audit SQL servers almost in a vulnerability assessment way, but I only want to look at those things that have the potential to escalate privileges. So I'm not looking at best practices. I'm looking specifically at things I've already proved can provide a low-level user sysadmin privileges. And then obviously I'm a pen tester, so I wanted that one button press to go from public role to sysadmin. Oh, excuse me one moment. It's allergy season in Minnesota, so I'm struggling with that a little bit. But we'll get through this. So currently, PowerUp SQL has 60 functions, or a little over 60 functions, that do everything from mostly recon work, actually. So pulling information about databases, about servers, about data within the database. But the primary functions map to those core functional goals I just talked about, which is dumping an inventory offline in CSV or like XML format, performing an audit that you can identify vulnerabilities without exploitation, and then the exploitation. And I have spent a lot of time trying to document this and provide cheat sheets and install guides. So if you actually go out to GitHub, at the GitHub repo, there's a wiki page there. That's essentially the source of all the documentation for it. Also, I have tried to document the functions individually, so GitHub does work with most of those functions. Like I said, it's out on GitHub. I also have it out on PowerShell Gallery, but at the moment, that's out of date. So hopefully I'll get that updated in the next week or so. There are lots of ways to install it. On the wiki, I outline them and kind of where it makes sense to use what method. All right, so most of the people on this call are already familiar with SQL Server Basics, but I just wanted to emphasize a few points for those who aren't. So at its core, SQL Server is just another application. It's a set of Windows services that runs on the OS, and those Windows services run in the context of the service account, and so that will become important later. And so every time you install an instance of SQL Server, you're essentially just installing a set of Windows services that are uniquely named. Also, we have different account types in SQL Server. The three big ones are Windows accounts, so by default, only Windows can authenticate. When you map a Windows account to SQL Server, it actually creates a pseudo, like a SQL login that's mapped directly to Windows. And so those accounts can also be created as standalone accounts in mixed mode so that they can be logged in to SQL Server directly, and that's used more often than not because of the way most application architectures work. But neither of those accounts by default has access to data unless you're sysadmin. They have to be actually explicitly mapped to users within each of the databases. So important notes. Two main roles that are worth noting: sysadmin, which is of course your it's kind of like a Windows administrator for SQL Server, and the public role, which is this least privileged role that should, in theory, only allow you to connect to the SQL Server and not really do anything beyond that, really. So it's kind of like the everyone group in Windows, but at the SQL Server layer. So with the basics out of the way, I thought I'd talk about finding SQL servers because it's pretty hard to attack them if you don't know where they are. So I've kind of broken this out by attacker perspective on the left, and then the general common techniques on the right. From an unauthenticated perspective, an attacker, when trying to find your databases, will use a lot of kind of standard scanning methods, so TCP, UDP broadcast methods that have been around forever. But now we live, of course, in this world of the cloud, and so as we're working with our clients, we see a lot of people putting their databases in Azure environments, and when they do that, they're given a subdomain essentially off of databases.windows.net, and so as an attacker, I can kind of indiscriminately do dictionary attacks against that subdomain to enumerate real database endpoints that are potentially exposed to the internet. And now, while talking to the Microsoft guys, they will tell you by default there is a firewall in place that prevents direct access, but what we're finding is that a lot of people are opening up that access to the internet way wider than it should be because they're not really sure where they're going to be actually coming from. So we're essentially taking what we've done a really good job of doing over the last like 20 years, which is putting our databases behind firewalls and DMZs, and now we're putting them back out on the perimeter networks. Another interesting thing to note from an unauthenticated perspective is a lot of people are syncing GitHub repositories with their Azure environments, and in some cases those repositories are public, and we're finding that there's quite a few repositories that are including these database endpoints along with the connection strings, which is literally exposing the entire database to the internet. So be careful if that's something you're doing at the moment. Finding local instances is pretty easy. We can just reference our services and registry entries. The one I find really interesting is domain user perspective, because when you install SQL Server on a domain system, it automatically registers that instance in Active Directory with the associated services count. And the reason it does that is to support Kerberos authentication. And so that information is actually pre-authenticated information, which means every domain user on the network can get a full list of all the SQL servers in the domain. So from a targeting and a reconnaissance perspective, as an attacker, that is incredibly valuable. And then naturally, we're still in the Azure environment, so if I compromise the right set of credentials or Azure is misconfigured, I may be able to actually leverage either the Azure portal directly or the PowerShell modules for SQL Server. I have created a few PowerUp SQL modules, or excuse me, functions to kind of support basic discovery. I am continuously building out additional functions, but these are kind of the core. The first will suck them in from a file, instances from a file, so they can be piped into other SQL Server commands as targets. Your traditional UDP scan, this is kind of like an SQL ping. Your local user listing, which as I mentioned uses the services, and then your domain level, the get SQL instance domain, will actually grab a full list of those SQL Server SPNs from the default domain controller you're associated with. So they're very, very handy. So I'm going to go into more detail on those in a little bit. For the meantime, let's assume that as an attacker, you've used one of those methods to identify an SQL server, and now we want to try to gain that initial foothold, that foot in the door, into at least a handful of SQL Server instances in the environment. So traditionally, there are maybe three major methods that people focus on. Dictionary attacks is still common today and still very effective. For the last 15 years, we've been using dictionary attacks with simple dictionaries like dev, dev, test, test, user, user to get access to database instances. It's unfortunately still really common. It has become actually a little less common after 2008 when they made the password policy inheritance default. I think that made a big difference on the whole, but still an option. The other one is default passwords based on the SQL Server instance name. When I say default passwords, I am not referring to SQL Server. Tons of applications ship with SQL Server Express as a backend, and very often in the install guides they'll say, be sure to use this instance name. This is our supported naming convention, and please configure with this default set of credentials. And so as an attacker, I can get a full list of SQL servers from the domain, and I can filter based on instance name and then try for defaults. And we've actually had a lot of success with this as a way to get initial entry into some of those databases. And lastly, local Windows and AD pass-through authentication. So just trying to access it using your current Windows credentials. So I've also created a set of functions to support these scenarios or use cases. Dictionary attack can support different files and user lists in various configurations. Default password test, the first one is an audit script, and the second one will just give you a table output, which is really nice, which you can pipe into other commands. And so there's a brief example of like how we would get a full list of domain servers, get SQL instance domain, and then we can just pipe that to give me the default list of logins. So pretty straightforward. And here's a screenshot of the default login function. This was just run on a local system that had 3 instances installed. So I enumerated my local instances there with the first command and then piped it to check for defaults. At this point, I have about 40 applications, instances, and their associated defaults, and so that will grow over time as well. I also have provided some cheat sheets basically for the different perspectives and commands. So unauthenticated local user and running as my current domain user. This is showing basically how do I test login access. So as a normal domain user, for example, how many SQL servers on my domain can I actually log into? The threadings there is by host. That's all the threading in PowerUp SQL is host-based. It's not request-based or query-based, just for the sake of clarity. And then at the moment, if you want to run as an alternative domain user, I'm using run as no profile to launch a new PowerShell process that will execute with a different user context over the network. However, based on some conversations with Chrissy, I might be able to bake that in long-term natively. Now, when you run most of these, especially the discovery commands, you're going to get an output list of what's accessible and what's not. But you may want to reuse that. So I've showed some examples of how to actually store the results in a variable here and then quickly reuse it to execute commands on scale against multiple databases or all the databases that are accessible in the environment. So here's a quick video outlining some of the stuff we've talked about so far. So here are just local instances, some of the information you get with that. Here's us selecting and formatting a list of SQL servers from the domain. This is just my tiny test environment with 9 instances. In real environments, enterprise environments, we see thousands and thousands of SQL servers. And so it's nice to have a full list of those. And from that, we can also do some fun PowerShellery and do things like grouping by the domain account. And this will basically tell us which SQL servers are using shared accounts in our environment pretty quickly, which is neat. And this will be important later. You can also filter by specific account. So if you have a service account and you just want to list what servers it's running on, you can use that extension as well. In this example now, I'm just enumerating all of the SQL Server instances and seeing whether they're accessible or not. But I really want to be able to reuse that information without having to rerun the discovery command every time. And so I'm going to assign it to a PowerShell variable, which is then going to contain that data table object. So we'll see it run the same thing, but out of the gate, it's not going to execute. And then down here, like I said before, now we have our targets list stored in that variable of accessible servers, and we can quickly pipe it into other PowerUp SQL Server commands and get server information, get database information, or any other information supported by the other functionality in PowerUp SQL. All right, so when we go through those types of activities in enterprise environments, what we're seeing on average is about 10% of these SQL servers in any given enterprise environment we get some foothold in, which is really an alarming number when you think about it. And so clients tend to ask the question, like, why can these domain users log in so many places? And the short answer is kind of twofold. First, admins give them access because they're on tight deadlines. They need to get their apps out. They don't necessarily understand the hard requirements, or they don't have the ability to add their own Active Directory groups that are configured with least privilege. The second, excuse me, is a privilege inheritance issue that exists with SQL Server Express that gives domain users the public role on the server. And kind of the way this works is when you install SQL Server, say on a domain system, Express by default won't have the listener open, but most people will open it for development to support their 2 to 3 tier applications. And by default, built-in users, the local built-in users, have the rights to log in, which doesn't seem like a big deal. But nested in that is the NT Authority authenticated users. Also, superficially, it doesn't seem like a big deal. But when your system is on the domain, that includes inherently the domain users. So what that means in summary is if you install SQL Server Express and open up a listener on a domain system, you inherently provide every domain user in that environment the rights to log in with public privileges. So that's pretty impactful, and so those two are kind of the main reason we get that 10% or more almost every time. So now we're assuming we have a foothold. In many cases, I should note about, I don't know, 20% of the 10% that we get are sysadmins out of the gate. So very often we're getting some type of sysadmin privilege starting from a domain user perspective. It's pretty common. But regardless, let's assume for the moment that we only have public role privileges, and now we want to work up to sysadmin privileges. We talked about this earlier. We can still use weaker default passwords with this foothold in various ways. What I didn't talk about was blind SQL server login enumeration and blind domain account enumeration. And so by default, when you actually try to select a full list of SQL logins from a from a SQL server, you should only see yourself and SA in the default roles. But there's functionality within SQL Server that will allow you to work around that using kind of standard fuzzing techniques. So just kind of walk through the two scenarios here quickly. First, we can attempt to access a full list of users. We can see we're only seeing a subset. Next, we're going to use a function called suser_ID, which gives us the principal ID of the SA account. But really what's interesting is the one that goes the other direction. So we can actually provide a principal ID, which is just a normal number, and we will get the actual principal name back. So we can see from the simple example, I'm able to actually kind of fuzz up and then see an account that I did not previously have visibility into. So if we go back one here, you can see it's my public user versus my hidden user. So we've actually can then increment that number and just repeat and get a whole list of SQL logins. And we found this to be an insanely effective technique, and it really increases, I guess, the effectiveness of the dictionary attacks because I have a function that will actually take the user and then try the username as a password, and we're literally finding hundreds of accounts that are configured with this. A lot are application accounts, some are just dev guys or sysadmin guys adding these accounts, but it's pretty prevalent throughout most environments. The second scenario here is domain user enumeration, and once again, these are all from the least privileged public role perspective. We can get the domain with the default domain function, and then from that, we can just create what we know to be a domain group. So I got the demo domain, And now I know domain admins exist in every Active Directory environment ever since the beginning of time. So I can hand that to the suser SID, and then I get a full RID for the domain admins group. From there, I can just chop off the unique identifier that's associated with the group and get the SID for the domain. At that point, I can then just create a number, convert it to hex, pad it out a little bit, slap it on the end, and now I have a new RID which would be associated with a domain object. And then I can pass that into the inverse function, which is suser_name, and now I've blindly enumerated the domain admin. And so similar to the other technique, we can increment and repeat. So here's a quick video of that. So first I'm just showing here using the one of the PowerUp SQL functions that I am not a sysadmin. And now I'm going to go through and do the SQL login enumeration. This is using the fuzzing function. And all its goal in life is to just fuzz stuff. Next, I'm going to actually try to use the username as password. And this will essentially run the same test, then actively try to log in, and then provide us what equates to a mini kind of vulnerability assessment specific to this vulnerability. So it will talk about the affected account and what the password was that was enumerated, as well as whether it's a sysadmin or not. So that can be really handy. And that's built into the default audit script we'll see later. Next, here's the domain enumeration or domain object enumeration. And while this doesn't seem super valuable during a direct penetration test, when we do this through SQL injection, it's actually insanely useful, because even if we can't escalate privileges on the domain or the SQL server that we've injected into, we can always enumerate domain users. So with a full domain user list, we can then try to do dictionary attacks from the internet using common passwords, which is an incredibly effective method, and then log in through non-two-factor interfaces like Citrix, terminal services, single-factor VPN, VDEs, those type of things. I did talk to Microsoft about this, and they said because I have to log in to do it, it's a non-issue. So technically, I guess it's not qualified as crossing a security boundary. But I tried. Next major category for escalating privileges is impersonation. So the whole idea behind escalating privileges is to get code or a command to run in the context of a user that has more privileges than you. So there's lots of ways to do this in SQL Server. Here are some of them. I'm sure it's an incomplete list, but these are the ones I've spent some time playing with. And I'll talk about most of them. The only one I don't really have baked in to PowerUp SQL yet are the agent jobs, and that's my next major area of focus. I'm still in my research phase with that, trying to understand where I need to use, what versions I need to use proxy accounts on, which versions I don't, and all the different roles and stuff associated with that. So hopefully that functionality will come out in the next couple months. But for now, the rest is pretty well covered. All right, the first item for impersonation is literally the impersonate privilege. So there is a privilege or permission in SQL Server which allows you to have a least privileged user impersonate a user with more access. Oops, there we go. From a dev perspective, the line of thinking isn't completely out there. They want, say there's a database account used by an application, they want to make sure that most of the time it's running in a least privileged context. And so while this can be used for that to a degree, the problem is, once again, kind of twofold. The first is if you're having that least privileged user run operating system commands, you have to set the database, associated database of the server procedure code you're running to trustworthy, which kind of softens the database security on a whole. The other thing is it in no way constrains what that user can do in the alternative user context. So if I allow, say, just the most extreme example, the public role to impersonate sysadmin or SA, they can do anything they want, and there's no limitations to it. So it can be very dangerous. And so here's a basic example of how this is executed. This is me just kind of showing myself running as my user who is not a sysadmin. And now I'm changing my user context using execute as login. So it's really nice functionality to have if you are a sysadmin and you're trying to understand how something's going to run as a lower privileged user. That's probably the more legitimate use case. But try not to assign least privileged users that kind of privilege, I guess, is the general recommendation. So we've actually seen that in a lot of applications. There's kind of a step up, which is let's take all that functionality we want the user to be able to execute in kind of that elevated context and put it inside a stored procedure, which is a nice idea. And to execute it and give it access to additional things, let's have it execute as the owner of the database. So this is nice for developers because you can still execute in another user's context. You can limit the commands, at least in theory, which is much better than letting them run whatever they want. And you don't have to grant that impersonate privilege, which is cool. But you don't have any granular control over the database owner's privileges. And in many cases, when people deploy applications, the actual SA account or a sysadmin account actually owns the database, and the DB owner role can then use the execute as owner to actually execute in the context of the sysadmin in that case. Also with this, we still have the database being marked as trustworthy as an issue. And if people are programming these insecurely and using concatenated strings all over the place, then SQL injection and command injection can be done kind of in an ad hoc basis to kind of extend the intended functionality of the stored procedure. So this is a really basic example in which there's a stored procedure with the execute as clause. It's pretty straightforward. This is really my favorite. A lot of people are now starting to use signed procedures. And so in my opinion, I think these are the more secure option for allowing users to execute specific functionality in an elevated context. So the process works: you create your procedure, you create a database key, create a cert from the key, create a login from the cert, and then you assign, in theory, only the privileges you need to that login, and then you sign the stored procedure with the cert, and then you can then grant execute on that stored procedure to even the public role. And in theory, if you did everything right, they shouldn't have access to execute arbitrary commands or anything like that. Although we have seen in some cases people essentially signing in with more or less sysadmin privileges, which is bad. The pros of this method, generally speaking, are you get the command execution in a different user context. You get to limit and constrain the queries. You don't have to do the impersonate. And now you get granular access control or granular control over the permissions, and you don't actually need to set the trustworthy flag on the database. So it's a really awesome option, in my opinion, but it can still suffer from SQL injection and command injection if you're doing the string concatenation within your stored procedures. So here's kind of a canonical example of what that looks like. We're ticking all over, which is bad, and so I did write some stored procedures to look for basic SQL injection as well. I forgot to put the actual screenshots in here, but there are multiple functions to do that, and they are included in the audit script by default. But here's just a basic example of extending the initial intended functionality and running an operating system command as sysadmin through an injection on a signed procedure. So that's kind of what it would look like in Management Studio. All right, another one that I think is kind of interesting is automatic execution of stored procedures. So most of you probably already know, but kind of like Windows where you can have startup folders for users, you can also flag stored procedures in the master database to run when the service restarts. And there's, excuse me, there are a lot of really legitimate use cases for this. As long as you know, a lower privilege user doesn't have any alter privileges to that stored procedure. So I did also write in a check for this one as well, since it's a real thing. So naturally, I didn't want to have to run, the whole goal of creating this kit, right, was so I didn't have to run all of those functions individually. And so audit will run it and just report on each of those issues. And so here's a quick video of invoke SQL audit. Once again, these are just high impact issues. Something that is worth noting is I recommend always using the verbose flag because you're going to see what's actually happening, especially when you're running this stuff on scale. It could look like the command is frozen when it's actually not. So it kind of gives you a real-time feed of what's going on. And here you can see audit spits out example exploit commands if you want to actually exploit it, descriptions, recommendations, affected accounts, things of that nature. And naturally, you can output to a variety of formats. Because it's a data table on the output, you can put it into another PowerShell command if you want. You can output to a CSV or grid view for quick searching. So all very handy methods. And then to take it a step further, I then added some functionality to each of those modules to then automatically escalate the current user. So if I'm connected to the SQL server with my domain account, and right now I only have public role access, what this is going to do is try to leverage those weak configurations we just saw and actually add my account to the sysadmins group. And so here, we're just repeating what we've seen in the past. We're creating a list of accessible targets, which we can see here. We're then going to use SQL Server Info, or get SQL Server Info, to see which systems we already have sysadmin privileges on. We can see we have it on one, but we also want it on that 2014 instance. So now we're going to run the escalation script against that server instance. It will run through all the different modules. Only difference being at the end, it will try to escalate our privileges, which it says it has. And finally, we can use that same server command we did before to validate that we have sysadmin privileges. So it's really useful during pen tests for trying to kind of illustrate risk to clients as well as sysadmins, trying to really understand if there's real potential for escalation. So now we're assuming, so now just to recap, we've done discovery, we've done gained an initial foothold in SQL Server, and we've escalated our privileges to sysadmin. And so now we want to move into from the database layer into the operating system layer, and we want to run as the service account. The reason for that is that when we actually execute operating system commands through SQL Server, it's done in the service account context. And I'll talk about why that's valuable on the next slide. But for now, I just wanted to emphasize that there are a lot of ways to execute operating system commands through SQL Server, and I'm probably not even listing them all here. But everyone hyperfixates on XP command shell. But you can specify your own .NET assemblies, write extended store procedures in C++, use jobs of various types, et cetera, et cetera. So there's way more options than most people consider. As I mentioned, when you do, let's just use XP command shell as an example because it's simple. When you execute that command, you're immediately executing commands in the context of the service account. You don't need to know the service account's password to execute commands as the service account. You don't need to acquire a password hash and crack it offline, and you don't need to pass the hash. You immediately are running as one of many types of service accounts. And so typically during a pen test, we're going to target domain users and domain admins because obviously they're going to allow us to escalate in the environment very quickly. And once we have something like domain administrative rights, we can then add ourselves to all the the SQL Server admin groups, and now we can look at data across the entire environment. So that's usually kind of our escalation path and why we focus on those two. But as of DerbyCon 2016, which was a security conference that happened in September, two guys, Chris Maltz and Steve Breen, found a way to basically escalate from any service account to local system. And so at the moment, this is, I think, a cross-protocol issue. Microsoft's looking at, but I don't think there's a patch yet. So for those of you who are interested, and I really do encourage you, go look at their website, check out the blog where they go into the details, and just try to understand what your risk profile is going to be within your environment. So once you've actually are executing commands, if you do want to execute things on scale, in this example, we see the $accessible, which is a variable containing a list of all accessible SQL servers we know about. And once again, simple pipe. We're piping it right into our OS command execution with a who am I, and we can see kind of who we're running as, but naturally that command could be anything you want it to be. All right. So service accounts are fun. We kind of understand the impact, at least locally. But we do see service accounts shared everywhere. So just to recap, sysadmins can execute OS commands. OS commands can run as a service account. And service accounts have sysadmin privileges by default, which is something we didn't previously talk about. So on a standalone system, that's not a big deal. But in a domain, it becomes very significant because in most enterprise environments, companies are using a single domain account to run hundreds of SQL servers. And what this means is, if you compromise a single SQL server, you have effectively compromised every single server that uses that shared domain account, for the reason that actually everyone I've ever seen in my professional career has given that service account local administrative privileges. So it's not just sysadmin access to the database, but it's also full administrative access to the underlying operating system. So it's an incredibly powerful kind of lateral movement technique. So I'll kind of illustrate that here in the next slide. So from an attacker perspective, we definitely do this during internal penetration tests where we can directly hit the databases, but we also do it through SQL injection. So in this example, we're going to come through the cloud, find an SQL injection on the app, which will allow us to poke through the DMZ to the backend database. And in many cases, this is a low-value application, like a marketing site or something, and we're able to get XP Command Shell running. But because they have the shared service account used to run every database in their environment, including the banking app, we're able to do this. We're able to actually execute commands and queries through XP Command Shell against other systems. And this isn't using advanced hacker tools. We could literally do this with OSSQL, SQLCMD, ISQL, whatever. All of them support the -E flag, which says just run in my current user context. And so you do that and then can run against the remote servers. So very powerful technique even with just native technology and no PowerShell. All right, this is a really cool escalation method that a lot of people aren't aware of. So for those of you who have not been exposed to what database links are, essentially a database link is a persistent connection between two servers. And so basically allows server A to communicate to server B and pull data from server B without having a user logged in. And those links can be configured in different ways. It can be configured to run as the current user who's logged in, but more often we see them used with hard-coded credentials, which can lead to privilege escalation because even members of that public role we talked about earlier has the right to select data on server B from server A over the link using the open query, because the open query function object thingy is basically available to everyone. So we can do simple things like just basic queries, but we can also run commands through them if we have sysadmin privileges over that link. And what really compounds this is that these links can be crawled or nested. And so from an attacker perspective, I put together this diagram. Once again, we come through, we find SQL injection. We're on that low-value application database, and we're not a sysadmin. We can't escalate privileges, but we do have a link to database 1. And that link is configured. It's hard-coded. It allows us to execute queries on DB1, but not as a sysadmin. But after looking at database 1, we find there are links there as well. And so that actually has a link over to our banking database, our high-value database, and that is configured as a sysadmin. And so now, not only do we have access to 3 servers instead of 1, we also now have the ability to execute operating system commands and escalate in the larger environment through that HVA server. So that's just a 2-hop example. We are actually seeing this in about half the environments and half the apps we work with, so it's a very prevalent technique. People are using it as kind of a distributed database model for SQL Server. The max hops we've seen is 12, so we saw 2 there. We've seen actually going through 12 unique servers. And the max number of servers crawled was 226. And it should be noted that because of the link relationships, there was actually thousands of links that resulted in access to 226 servers, 225 of which we had sysadmin privileges on. So it can get out of control very quickly. Antti Rantasari and myself have presented on this topic a number of times and created some toolkits in Metasploit, but he recently rewrote a lot of it in PowerShell. And so right now, if you go to PowerShell in the scripts directory, you can actually see his script. And eventually that will be rolled in. So this is a demo of his work. Essentially, we're going to connect to our initial server, and it will grab some information about every instance that it hits. It will grab the link user, in this case SA. It will tell you whether it's a sysadmin or not, and it will tell you the number of links on that server. And then it tries to give you a list of those link servers and the path. And as it continues to crawl through these links, kind of like website links almost, with kind of a standard recursive query, we can kind of see these link paths getting bigger and bigger. And then at the end, what it will provide is, once again, it's a data table output, so you can output it to CSV or XML or just a flat file, or piped into other commands. But so it does give you an overview of what your links are, where the broken links are, versions of your operating system, and which ones have sysadmin. And it's not shown here, but it does actually support command execution and query execution, which is very powerful during pen tests. I guess I should note here that we have done a number of pen tests where we've started to crawl through an SQL injection, and we've stayed within the organization, and then because they have relationships with business partners, we've actually seen it crawl out to other business partners, and naturally when we see that, we stop the test and start the crawl. But just to prove the point that this might not, the way that people currently use links, it crosses network segmentation boundaries, and it crosses company boundaries as well. I got kind of turned on to Neo4j, which is this cool graphing engine by actually the Bloodhound Gang guys who do some other visualizations. But this is one example from a recent test, which was a single crawl. I hit one server and then kind of crawled out and mapped using Auntie's crawler and then popped it in Neo4j. And so you can see how many links are really there, which is an insane amount. And once again, we saw in this particular environment, we saw 3,000 servers, about 250 or 200 we had access to, and this is only one example of a crawl as opposed to the other 249. So that was one of my favorites. This is probably my favorite escalation method because it is so widespread, and we do use it quite a bit to escalate domain privileges during internal penetration tests and red team engagements. We'll kind of start from the beginning. So UNC paths are used to basically access files on remote servers using that kind of format. Almost all store procedures that accept a file path in SQL Server support UNC paths, and that's because of the underlying libraries that SQL Server wraps. The interesting thing is though, when SQL Server actually tries to go and grab that file, it doesn't do it under your current user context. It does it under the context of the service account that's running SQL Server. What this means is, as an attacker, if we can execute one of those functions, we can force the SQL Server to authenticate to us, at which point we can capture its net NTLM password hash and either crack it offline or relay it. And so now at that point, we would have the service account, and as we talked about before, all the service accounts have sysadmin by default, so we'd be inherently a DBA if not a local admin. We can also relay between servers, and this becomes really easy, especially when we know what service accounts are running on what server, so we basically know there's kind of an inherent trust relationship. So that would kind of look like this. As an attacker, I sign in with least privilege over on server A. I use some type of UNC path injection on a function to force the service account to authenticate to me, and then instead of taking that, I'm just going to forward it on or relay it to another server that's configured with the same service account, and it will say, yep, your authentication looks good, and at that point I can then execute arbitrary commands on that second server, as long as SMB signing's disabled. So that's an important control if you're trying to prevent the relay scenario. So this is a really interesting attack because public role, by default, has two procedures that accept file paths, XP directory and file exists. So we can, in summary, the public role basically has access, direct access almost, to the SQL Server service account net NTLM password hash by default on every version of SQL Server excluding Azure. So it's incredibly useful, incredibly versatile in every environment with every version of SQL Server. So that's pretty impactful for us. So I've explained that to some clients, and they say, okay, so what? The public role can get the service account, the service account's a sysadmin, but who really has public role access? And then I remind them, yep, a ton of your domain users have it because of those two reasons we talked about kind of in the beginning of the presentation. So lots of exposure. So I created a proof of concept script for that as well. The way this is going to work is we're going to import, because it's not fully integrated into PowerShell yet, it's a standalone script in that same scripts directory off the GitHub repository. We're going to import PowerShell first. Then we're going to import this amazing toolkit by Kevin Robertson called Inve. And what this does is it can spoof responses and spoof NBNS and LLMNR responses and collect password hashes as authentication requests are made to it. So that's all written in PowerShell, and he's just done an incredible job, which really enables me to automate this entire process. So here we're loading PowerUp SQL, we're loading Envy, excuse me, and then loading my standalone script. And we're going to point it to myself. So the IP I'm specifying is actually my attacking IP address. And so what this is going to do when I execute it is it's going to go out to the default domain controller for the server, grab a list of all the SQL servers, attempt to connect to them, and then do UNC path injection and collect the password hashes. And so we can see immediately we're starting to get password hashes back. And it may not look like much, but what we're seeing here actually is what's going to give us access or unauthorized access to all these servers in the environment. And so this might seem like actually a lot, but in a real environment, like I said, there's thousands, hundreds to thousands of servers, many of which we'll get access to. And so we get a huge flood of these, which give us a lot of options for escalating on the domain. So once we've actually taken over some servers, we have access to a lot of different SQL servers. We've kind of talked about a lot of different scenarios, but one common scenario is still I get onto an SQL server as a local admin, but I don't have sysadmin privileges. I can't even log in. So people want to be able to get access to the data as well. So there's two things to think about here. The first is different SQL server versions, or be aware of, can be abused in different ways. But once again, just reminding you that all versions of SQL Server provide the service account with sysadmin privileges. So it's kind of a recurring theme. So there are a lot of techniques that we can leverage to that end that I kind of have mapped out by version of SQL Server. And this is, I'm pretty sure all these are accurate. The first item here is LSA secrets. So when any service account in Windows is used, if you configure a domain account or a local account, it actually stores that encrypted in LSA secrets. And so that's typically, I think, encrypted with the machine key, but because it's stored on the system, if you get local system access on a box, which is very common during pen tests, you can actually reverse that process and pull out the clear text password for any given Windows service account, and that includes SQL Server. And because that's a Windows piece of functionality that still exists in all versions, you can do it in all versions of SQL Server that I'm aware of. Older versions, you can be simply a local administrator or local system. You can also do what's commonly referred to as process migration, and that's when you literally inject a DLL or shellcode into the SQL Server service process. While this is a very effective technique, it is a little bit more dangerous than the other ones. The nice thing about the other ones we mentioned already is cool because you don't have to restart the SQL Server service at all. Process migration, you don't either, but if anything goes wrong, you're going to crash a production service, which no one's going to appreciate. So although it's an option, I would steer away from it. The other really nice one is token stealing. So basically creating a copy of the authentication token assigned to the SQL Server process and then spawning a new process in the user context. So that's really neat. And then single user mode. And this is, single user mode is, I think, does require a restart. This is pretty new to me, actually, because of the DBA tools exposure. But I'm still kind of getting my hands or head around it here. I believe it works based on, I guess, Chrissy's documentation between 2005 version and 2016. So lots of variability. If you're looking for tool sets that do these things, I've kind of listed them out there. Feel free to take those offline and kind of choose what makes sense for your particular scenario. So now we're assuming at this point we've taken over SQL Server a variety of ways. We have some maybe even domain admin privileges at this point, and we want to do some common post-exploitation activities. The first and most common is establishing persistence, meaning I'm basically going to backdoor the server. SQL Server is really neat because a lot of the escalation methods I mentioned before can actually be used as persistence methods. So creating a malicious startup procedure, a malicious agent job, a malicious trigger, modifying existing code. All these things are ways to maintain persistence in SQL Server. Execute operating system commands or database commands, whatever. And the really neat thing about this, from a red team perspective, is that I don't have to drop any files on disk or make any registry changes. So they're all stored as SQL objects in the database. So most red team or blue teams, or kind of like incident response teams, won't have visibility into those types of persistence methods. However, there is if you do configure auditing in SQL Server, you can watch for those types of things. And then naturally, because SQL Server is so integrated with the operating system, both at the file and registry level, any persistent method you might use in Windows, like shared tasks, services, or what have you, can all be done through SQL Server. The next big thing is naturally identifying sensitive data in the environment. If, for example, you ran the get SQL instance domain command, you get a full list of your domain SQL servers. You could pipe that into get SQL databases, and it would give you a ton of database information that you could then sort, for example, by database size. And sometimes that can be a big indicator of where critical data is stored. Not always, but actually very often. The second thing that we found is really interesting is transparent encryption in databases. So you can use that same command. You can filter out the databases that have transparent encryption. Usually that means they're protecting data. The interesting thing about it is that transparent encryption is really only valuable if someone steals your backup to your database, and there's no keys with it. It's really just the files or the data. If someone walks away with the actual computer physically, they should be able to get sysadmin using the techniques we talked about, log in, and then it transparently decrypts that information. At least that's been my experience with it. I'd love to hear other information if people have had different experiences with it, but that's what we've seen. So we typically look for those types of things. Very often it's used to meet PCI requirements. So if people are storing cardholder data, we will target those databases for that reason. Also, there's kind of low-tech options, so we can pipe in, get all the data SQL Server instances into a couple other functions I'll show in a sec to search by column keywords. So if the column is named password, for example, or named social security number, etc., we can search and return data sets there. And then naturally, standard regular expressions, Lund formula stuff for validating data patterns. Then lastly, there's exfiltrating data. It's so easy to get data out of environments that I haven't even started to build out exfiltration functions yet. I do have a roadmap for all the function categories out on the wiki. So long term I'll be doing it, but we don't have it right now. Some interesting novelties are, though, in older versions of SQL Server, you can literally post data. If you have sysadmin access, you can create post get statements. And also today, even, you can email out the results of a query pretty simply. And so that is another one we see people actually using in real life, which is interesting. So lots of options. I have one persistence example here. I currently only have two modules for persistence. One is an auto run that will run every time you start the server or log in. The other is a debugger backdoor. So in this command example, you can see we're targeting the util man, which is that Windows key U. And instead of running your utility manager, what this will do is run cmd.exe. And what that means from an attacker perspective, if I do that through SQL Server, I can hit that system via RDP, hit the Windows key U, and instead of getting utility manager, I get an interactive system console running actually as local system. So this is a technique that has been pretty commonly seen both from attackers and pen testers. I also have some cheat sheets. There's a full cheat sheet for most of these scenarios out on the wiki, but here's another example of finding encrypted databases and finding and sampling columns. But in the interest of saving time, I'll go straight to the data discovery demo. So in this case, we're importing PowerShell. We're discovering the SQL instances on the domain and piping it directly into SQL column sample data threaded. We're going to be sampling 2 rows, essentially, from each column that matches, and searching for the keywords credit, card, and password. And we're excluding all default databases because we don't need a lot of white noise. So a lot of these functions support that no defaults flag, so it'll filter out master, MSDB, temp, etc. So in the results, once again, you can kind of see live what's happening, and you get the kind of fully qualified path to the column. So computer name, instance name, the database itself that's affected, the schema table, and then a sample of the data so you can kind of do quick validation. And then once again, this is output in data table format, so you can pipe it to a CSV or grid view or whatever you want. So that lands us on recommendations. At a high level, enforce least privilege everywhere. Links, service accounts, SQL accounts, all the store procedures and impersonation you're configuring. Always only provide what you really need to, and be conscious of that. Be careful with shared accounts, and with the shared accounts, also try to, if you're going to use them, at least just group them per cluster instead of between applications. Really, each app should have its own service account. Otherwise, you have that trust relationship we talked about. Naturally, you want to disable those extremely dangerous store procedures we discussed. Audit and fix insecure configurations on an ongoing basis. As time goes on, more techniques are going to come out, and so it's important that you're looking at the database layer and not just your application code when you're doing these kind of security reviews during your release cycles and things like that. I'm also kind of a fan of the policy-based management, so you can create some standardization there. To be fair, like I said, I'm not a DBA and I haven't managed hundreds of SQL servers, but from what I've read and played with, it seems like a really effective method. So I'd love to get feedback on that if anyone has it. And then generally, I have played a lot with the auditing at the server and database levels, and so almost every attack I talked about today, you can actually create event IDs for and use regexes or pattern matching to identify most of those attacks. So pretty awesome, pretty powerful. Microsoft's done a very good job making that available. I also wanted to just have this one slide here to give a thanks to everyone in the community. I don't know a lot of these people personally, but their public work and community involvement has really allowed me to build Power Up SQL, automate a lot of the techniques that used to take me a week, I can now do in like 5 minutes. So it's really incredible. I appreciate their help and everyone who's contributed and gave me design advice. So with that, I guess I can open it up for questions.
Yep, this is some really great content, and a lot of people are still hanging with us, so we're going to let this run a little long, and if people have questions, to get them answered as quick as possible. But we definitely don't want to cut it off short because we're loving the content.
Yeah, the feedback that I've gotten has been really exciting. This was super awesome to watch, Scott. I really enjoyed it. The first question is Akil asked, can using managed service accounts, is it any better than using a normal service account?
In theory, it is. I mean, especially for local accounts, it has, unlike a local service or a network service, it limits the privileges of the SQL service account to more or less only the things that it needs. So, although recently with the rotten potato attack, that kind of shatters that assumption, but historically that has been true. So I definitely encourage people to use managed accounts where they can.
Awesome. Somebody said,
Scott,
go on.
Just wanted to say, while we're waiting for more questions to come in, you were saying once the data is in a .NET data table, you can do a lot with it. And as of last month, you can actually take that information and write it straight back into SQL Server now.
That's awesome.
Yep. What? I didn't even know this. What did I miss?
Right, SQL table data.
What? Oh, that was the one. Oh my God. Okay, so I've been in the haze. Yeah. I didn't, because the name changed slightly, so I didn't realize that's what it was. That's super awesome.
Yep. We'll put the download link out in for everyone. Chris, did you have another question? I'm going to mute out.
Yeah. Just go ahead and mute out. So somebody said, great presentation. Thank you. Will this be posted? And yes, it will be posted at sequelps.io/YouTube. And I'm the one who does the posting. So once it's been encoded, I'll just go ahead and upload it.
Right.
We have another question that says, awesome, great presentation. Is it better to use NT accounts than ordinary domain accounts?
NT accounts. I guess
those are like the local accounts instead of a domain account.
The local accounts? Yeah, I mean, if you only need to run it locally and you're not using, I mean, for clustering, I believe it's required to use a shared account of some kind or shared managed account or something like that. But if you're just using it like an application that has a local Express instance, yeah, definitely don't use the domain unless you have to, because you are really exposing yourself to that larger environment.
That's a very good point. Somebody also said, are there any plans to integrate with Empire, PowerSploit, or any other framework?
I've been talking to the Empire guys. I've already, I guess I'll start with Metasploit. I've already written a number of modules that do about half of this stuff in Metasploit. They've been there for a while. Um, they don't do the SPN stuff, but they do a lot of the other things, kind of onesie twosie, and there are also some SQL injection modules written for Metasploit specifically. As far as Empire, we were talking to the Empire team and the Bloodhound team about integration opportunities, and we are trying to write at least a handful of the core functions for Empire at the moment, but we're just not there yet. So when that happens, we'll definitely share over the tweeters and all the other mediums.
Awesome. Thank you. And then we got a whole bunch of yays. Like, thanks for sharing and thanks for this excellent and scary presentation.
Happy to share. Just in closing, with the database links, someone did make a note, which was good. I keep calling them database links, and they're linked servers. My language is a little off there, so sorry for the hardcore DBAs in the group. Also, the links can be used to communicate to files, read files off the disk, talk to Active Directory, talk to other database platforms like Oracle, MySQL, and we have seen that. It's such a large scope, I decided not to include it in the deck, but good comments.
Cool. Well, thank you so much, Scott.
So
let's
is there
see.
no way to secure XP command shell? Is it you just need to turn that off, or is there a way to do it?
There's really no way to prevent command execution once you've acquired sysadmin privileges. XP command shell specifically is basically a DLL export. And so even if you completely unregister it, you can still point to the native DLL, re-register it, and re-enable it if you have sysadmin access. So I would definitely leave it disabled, which is now the default by Microsoft and has been since 2008, version 2008. But it's really not the core problem. Privilege management's more of the problem, I'd say.
That makes me wonder actually if enum directories. So if you have like an SMO server, do you work with SMO a lot, right? Or do you mostly stay with the .NET objects?
I've done both, but I've been kind of in .NET land for the last year or so.
Well, with SMO, there's a .enum directories, and I've never run a trace to see what was going on in the background. But if it's disabled by default, is this for everyone, including administrators?
Yeah, by default, even for admins, you can't use this. XP command shell without first enabling it, which is actually good in the way that you can enable logging and auditing on it, and actually link that to your SIMs internally. So if someone starts enabling that, you'll at least get a warning.
Oh, I actually may have gotten it confused because I saw that you were running one of the ones that I believe that runs in the background, which is like XP _ directory listing or something to that effect.
Sorry, the dir tree.
Yeah.
Sorry, my apologies. So the question was, is that enabled by default? Sorry.
Yeah, well, that's my question. I don't think that was that was his question. I totally got confused.
It's all good. It's my bad. I confuse things. XP Dirtree and XP File Exist are both enabled by default in every version of SQL Server from 2000 to 2016, excluding the Azure flavor.
Excellent. Okay. Good to know, because I do make use of it. I try to over the actual SQL commands themselves. So it says, thank you for the presentation. Eye-opening and indeed scary. XP command shell proxy accounts only work for non-SA users. Oh, that's from CK. What's up? Someone else mentioned, let's see, trying to expand this. Oh, no, I can't. Oh, let's see. Sweet. Oh, thank you so much. Al-Jahai? Damn, I know that I totally messed that up. Sorry, I'm Cajun. He said, awesome. Thanks, Chrissy, for clarifying. You rock. I've been playing around with your DBA tools modules. Can't wait for more release and added features. That'll come very soon, in the next week, actually. And we have another one. He said, I'm a novice in DBA role and trying to learn as much as I can. I love Posh and automation, hopefully. I'll see you at PASS next week and introduce myself. Thank you. So thank you so much. This has been such an exciting presentation. I know that all of us were really excited to watch you and learn more. And this is definitely one of the ones that I'm going to download and watch again. And also your slides, actually his slides, I'm going to ask for them. And if he is kind enough to grant them, I will put them up at sequelps.io/slides. So that we can download all of the slides.
Great.
Sweet. All right. Well, thank you all for joining. This has been super fun.
Yep. Thanks, Scott. We really appreciate it. Chrissy, do you want to go ahead and stop recording?
I do. Thank you. Thank you all.